All right, we're back. We're still on page 73 of math analysis, and we are moving on to a new strategy for verifying identities, and it is the following. It's kind of like my last ditch effort, really. So it is to, oh, we're doing a highlighting thing. Let's see. I think I didn't use this color yet on this bit. Yep, here we go. Strategy number 8 is convert everything to sines and cosines and hope your algebra skills can carry you through. So this one, I always feel very defeated when I use this. But like, it's fine, I guess, whatever. So this is when you don't really see anything obvious that you can do, which like right now, I don't really see anything obvious that I would do. I don't know, like somehow I got to get rid of the denominator, right? Like on the left-hand side. So, but what would I do to make that happen? So I'm going to do it. I'm going to turn everything into sines and cosines. I was looking for like a clever way of doing this one. Maybe I'll come up with it as we're doing it. Yeah, I think we can. I think we might be able to, but let's see. So first, option 1. We're going all sines and cosines. So, and it's okay. Like sometimes you got to do it. So tangent, I know, is sine over cosine. And then cotangent, I know, is cosine over sine over. And then tangent, we know, is sine over cosine. This way is also a lot of writing, which, is everybody's favorite. Okay, there we go. So now, I see a lot of fractions that I can probably combine. So I'm going to focus on like just the so we're going to go just the numerator. And then after I'm done with the numerator, I'm going to do just the denominator. So that's what's happening here. I'm going to work on that. So in the numerator, I'm going to get sine squared minus cosine squared over sine times cosine. Sine, cosine. And all over. In the denominator, I'm going to get sine squared, sine squared plus cosine squared. So that's good, because that's 1. Anytime that shows up, be happy, over sine times cosine. All right, so things are looking pretty good. I'm going to highlight these again, just to kind of like show you where things are coming from. I feel like visually that's kind of maybe potentially helpful. I don't really know. I don't watch my own videos. So this whole thing is this whole thing is sine squared minus cosine squared. Like you can see it right now. But I'm going to do another step. But I am running out of space. So let me move this up. And then, I can't move stuff up much more, but I guess that way. So complex fraction. So let's simplify that into sine. So since they have the same denominator, this is a rule that I feel like not enough people really take advantage of. They have the same denominator, which means they might as well not have a denominator. Like you can just cancel those, right? Because you're going to multiply by the reciprocal. The denominator of the bottom, the denominator of the denominator is going to end up on kind of the top, right? The denominator of the numerator ends up kind of on the bottom. So here's what happens, and I'm going to delete this after I write it. You have like a over b, and then c over also b. That's going to be a over b times b over c. And you can see those are going to cancel. So you can cancel them without doing it. Another way of thinking about it is you could think that you're multiplying the top. So you could think that you're multiplying by sine times cosine over sine times cosine, right? And if you do that, that's just multiplying by 1. And then the sign in the numerator of your sine cosine over sine cosine, maybe I should be writing this. You can multiply by, where do I have space? All right, you know what? We're going off the rails. I'm gonna do it in a weird color because I shouldn't really be doing it. So you multiply this by sine cosine over sine, all by way of saying like get good at fractions. It's basically what I'm saying here. Once you have this, right, the one that's here in the numerator will cancel with this. The one that's here in the denominator will cancel with this, and you're gone, right? So all of that can take care of this for you. I'm going to delete this, go back to my nice black marker, and say that I ended up with this over sine squared plus cosine squared. And then sine squared plus cosine squared is 1, so we did it. Sine squared minus cosine squared. Well, hopefully we did it. There's nothing worse than when you like completely simplify and you're like, yes, I'm done. And then you finally look over at the other side and you're like, that's not what I was going for. But in this case, it is what we were going for. So mission accomplished. All right, is there another way we could do this? I mean, there's a lot of ways that we can do this. I'm gonna try something potentially weird. I don't know. So what I wanna do is I'm gonna go back to the beginning here. I've got tan x. I don't know that this is gonna help. Minus cotan of x over tan x plus cotan of x. Okay, so what I'm gonna try to do is I'm gonna multiply. So what do I know? I know that tan squared plus 1 equals secant squared. So that's kind of useful. I know that tangent times cotangent is 1 because tangent equals 1 over cotangent, or cotangent equals 1 over tangent. That's another thing. So I don't know. I'm gonna do something really weird. I'm gonna multiply the top and the bottom by 1 over tangent and see what happens. I feel like potentially that will help, but also maybe not. I don't know. Let's see. So we're going, or is 1 over cotangent better? No, I don't think it is. 1 over, so here, let me use another color because this is a dicey thing. 1 over tangent over 1 over tangent. And then I'm going to distribute that. And when I distribute, I'm going to end up with, also, by the way, I don't know if this is going to work. I get 1 over tangent times tangent is 1 minus 1 over tangent is just cotangent. So I get 1 over tangent times cotangent is just cotangent times cotangent. So cotangent squared, which I don't know, maybe that's useful. 1 over tangent times tangent is 1. And then this is going to give me plus cotan squared. For the same reason, right? 1 over tangent is cotangent, cotangent times cotangent. So why do I feel like this is almost done? Well, I kind of feel like this is almost potentially maybe done because 1 plus cotangent is, 1 plus cotangent squared rather, is cosecant squared. So right now I have 1 minus cotan squared over cosecant squared. But you'll see I'm gonna end up in the same place where I'm gonna have to convert. 1 over cosecant is sine. So really at this step, I have sine squared times 1 minus, what is cotangent? Cotangent is cosine over sine. So I'm going to say this is cosine squared over sine squared. And then if I distribute, I get sine squared minus cosine squared, which I really hope is what I was going for, which is, woo! So sine squared minus cosine squared. And there you go. So that's another way to do it. There's never one right way. There's always a ton of ways. And it just depends. I mean, like sometimes if you're doing a really hard one, you'll find yourself doing like 10 steps. And then when you look at like your 11th step, you're like, oh, somehow I got back to my 3rd step. Like you just like do things and then undo them. And like you don't even realize you're doing it. I'm actually just going to talk about this page because there's nothing to do on it. We got one more strategy here. And this is a purely academic strategy where, you know, you're only doing this because you're challenging yourself and you're trying really hard identities. This won't work when you get to calculus and you actually like need to turn one thing into another thing because you'll never know what the other thing is. But I use this a lot on really hard ones. You can actually work on the left-hand side until you're stumped. Then switch over and work on the right-hand side until you're stumped. And then if you can somehow work on them, so like I always imagine that the work for this will look something like on the left hand side you have like well, not like that. You'll have like A and you turn into B, C, D, E, right? Like you're just turning it into things. So this is your left hand side. Then your right hand side. So you give up at that point on the left hand side. You're like, there's too many steps. It's not getting anywhere. Looks kind of like, I don't know. I wish I knew the alphabet well enough to start at like a letter that would end me at E again, but I don't. So I'm gonna say like M, N, Q. You skip O because O looks like 0. R, and then E pops up again. It's like, oh my God. As soon as I get here, they must be equal because I turned both of them into the same thing. So by the transitive property, that means that A must be equal to M. What you could do if you wanted to is you can, then work on this side, like go down this until you get here, and then look at what you had here and literally reverse your steps and go this way, and you'll get it in one shot and it looks like you didn't work on both sides, but that's just vanity. If you don't want people to think that you've been doing that, you would use that strategy. But working on the left and the right, it's okay on a really hard one. I don't really recommend it, but like, it'll work. So what you need to do is a million of these. On my website, if you're in my class, there is a file that you can access. If you're not in my class, you won't be able to access it. I will not give you permission, so don't bother requesting. But just go online and search them up, right? Like OpenStax, I think, has a trig book and a pre-calculus book, and there's got to be identities in it, or find some sample chapters, whatever. There's plenty of practice problems out there. So this is just a summary box that has all of the strategies, and that's the end of this. So I will be back in the next video to continue on the next page, but what you should probably do is watch the other videos that I have for these notes, where I go over the strategies again, I do more examples, and then there are a bunch of videos where I'm just doing challenging ones, and I think it's a really good idea to kind of watch those. So go check those out, and I will see you in the next video.